Alright. Many people say that you either work geometry or you work algebra, you never work them together. Well, I won't lie. I used to be one of those people who really firmly believed that it was either algebra or geometry, that they didn't combine, they were two separate maths. But I'm here to tell you that that is not actually true. We use geometric ideas within our algebra because when you're looking at shapes, there's a lot of algebra to solving those shapes. And so here, what I wanted to do is look at a couple different word problems where we are implementing some geometry ideas into those algebraic problems, specifically through the use of area, perimeter, or Pythagoreans Theorem. To get there, though, we need to have a mini refresher, which is what exactly is the equation for the area of a rectangle. Well, when we're talking about area, we're talking about taking your length times your width, because we want to know what would cover the square. So here my area is going to be length times width. When we're talking about a triangle, we're talking about the same thing. We want to be able to cover it. So here we're looking at doing 1/2 your base times your height. Now, in terms of right triangles, we've got that very famous Pythagoreans theorem, which says that a squared plus b squared equals c squared. Now, this theorem is used in order to find missing side lengths. It's really, really big in construction or architecture when you know, say, how tall your wall is going to be, and you need to put a support, and you know how far away from the wall it has to be, but you need to know that diagonal, and all those kinds of fun things. Pythagoreans theorem is the theorem that really helps with that. Now, all that being said, you have to be able to read a word problem, and then you have to apply the appropriate equation to that particular problem. So I have a problem here that says the width of a rectangle is 4 feet less than the length. So first of all, this less than piece, again, is talking about subtraction. So here we're going to subtract. But because it says less than, it means the length goes first and the 4 feet goes last. So we're talking about a rectangle here. So I would highly recommend, if you talk about a rectangle, you draw yourself a rectangle. So here we are speaking about your width, and we're saying that it is going to be 4 feet less than the length, so that is length minus 4. Now we're told that the area is 117 square feet. So my area is going to be 117 square feet, which means the only thing that's missing is your length. And the question says find the length and width of the rectangle. So here we have to go back to the fact that we know your area is length times width, and we have to use that idea in order to solve. So we have that my area, so 110 feet, or 117, sorry about that, 117 feet is going to be length, which we don't know, times my width, which we said was length minus 4. Distribute the L, and we have that 117 is equal to L squared minus 4L. Move that 117 over, and we have 0 is equal to L squared minus 4L minus 117. Again, we need to factor it into its parts. So to do that, we need to recognize a couple pieces. First, this back term tells you that my factors are going to be positive times negative. This front term here tells you that the bigger factor is negative. So we need factors of 117 that are going to give me 4. So here, when we're looking at those, we're going to have L plus 9 times L minus 13 equals 0. So obviously you could take your 117 and list their factors out and figure out which combination works the best. And then in this case, when we solve, we get that L is negative 9 and L is 13. Now think about length for a minute. When we're talking about length of anything, it must be positive. Okay? So when we are talking about, say, units of measure must be positive. Okay, so let me make that note here for you. So units of measure must be positive. Okay, what this means is that they cannot be negative. So when you're working with these problems and you're trying to solve, when you come up with a negative answer, it means that you can automatically disregard it. So my length here is going to be 13. So that is what we found. So we found length to be 13 feet. Which means here my width is going to be 13 minus 4, which equals 9 feet. And that's all there was. We have found the length, we found the width, and we are good to go. Okay, let's look at another one. The base of a triangle exceeds the height by 5 meters. If the area is 42 square meters, find the length of the base and the height of the triangle. So we have a triangle here. So again, if you talk about a triangle, I highly suggest you draw yourself a triangle. Now what do we know? We know the base is the bottom and the height is the vertical height inside from base up to the point. And here we're also told that the base of the triangle exceeds the height by 5 meters. So that means this is going to be h plus 5. So exceeds means bigger. So what we're actually saying is take your height, add 5, and you get your base. Now the other thing that we're telling you is that your area is 42. So your area here is 42 meters squared. So again, we have to remember the definition. Area is going to be 1/2 base times height. So in this case, we have that 42 is equal to 1/2 times h plus 5 times height. Now the first thing that I would do is get rid of that fraction. So I would take this whole thing and multiply it by 2, which is going to get rid of that fraction, make it a little easier to deal with. So here we're going to end up with 84 is equal to h times h plus 5. Distribute the h through, and we get that 84 is equal to h squared plus 5h. Get standard form. 0 is equal to my h squared plus 5h minus 84. Again, pay attention to the information we have. So again, this tells us we're going to use positive times negative. And this front one tells us here that the bigger factor is positive. So we need factors of 84 that are going to combine together and give me 5. So in this case, we're going to end up with h plus 12 times h minus 7 equals 0. Set each equal to 0 and solve. We get h equals the negative 12 and h equals 7. Once again, we are talking about units of measure, so this one goes away. Now that we know what our height is going to be the 7 meters. So your height is 7 meters, which means your base is going to be 7 plus 5, which is 12 meters. Okay, let's look at one more. An architect wants to draw a rectangle with a diagonal of 13 inches. So first, what does that mean? Here we're going to have a rectangle, kind of like this one. We don't know anything about it yet, but we do know that it's going to have this diagonal here that cuts, and it is supposed to be 13 inches. We're told that the length of the rectangle needs to be 2 inches more than twice the width. So again, if you look, we have this more than piece. More means we're going to add. This twice the width part has to go before the 2 because it's a turnaround phrase. So this means we're talking about the length of the rectangle is going to be twice the width plus 2 more inches. And then that means this is my width. And it says, what dimension should she make the rectangle? So here, because we're talking about this diagonal, you can see that what we actually have here is a right triangle. So we want to use a squared plus b squared equals c squared. Sorry, don't know what that was. Now in this case, my a would be like my width. My b would be the length, so twice the width plus 2 is equal to 13 squared. So here I've got my width squared plus 4w squared plus 8w plus 4 equals 169. All told, we have 5w squared plus my 8w. I'm going to move that 169 over, so this is going to be minus 165 is equal to 0. There is nothing that I can do in order to reduce that down, so the only thing that I am left with doing is solving. So there are a couple different ways that you can solve this, and this is all personal preference. The first thing that you can do is you can use your AC method. For those of you that have watched previous lectures, this is my bottoms up method that I've talked about. The second thing that you can do is you can use the reverse FOIL idea, which essentially means go straight into factored form. And then the third thing that you could try would be what's called trial and error. Now that's a method that I don't necessarily recommend. It's a very tedious method, and it involves looking at all potential possibilities across all potential factors to find the one that works. Now with trial and error, you can either get very lucky in the very beginning, or it's going to take you until maybe your last factor possibility before you actually find the full answer. So like I said, it is completely up to you, but it is not a method that I recommend. Alright, so the first thing that I'm going to show you is that AC method. And so the AC method is very simple. It says the first thing you do is you start out by doing A times C. So in this case, we would be doing 5 times 165 so that gives us 825. Now with that, I need to find a combination that's going to give me 8. So when I'm looking at 825, the next thing that you need to do is we need to start finding those factors. So we have 1 and 825. We have 3 and 275. Five and 165. $11 and 75. $15 and 55. $25 and 33. And so here we have to look at which one of these combinations is going to give me what I want. Okay? So just like before, this middle term here is going to tell me that the bigger factor has to be positive. So when I'm looking at that, that means that these bigger factors here all have to be positive, which means the smaller factors are negative. So I need to know which combination of these gives me 8, and so the only combination that's going to work is this bottom one here. Once you know the combination that works, then what you have to do is you have to put it into the factored form. So the factored form says we're going to do x plus or minus we're going to put your factor, divide it by the a term, and that's how we're going to create them. So here, this first one is going to be x minus, it's going to be 25 over 5. And then we're going to have x plus 33 over 5. Now once we do that, we have to reduce our fractions. So we want to reduce the fractions as far as they can go. This first one reduces down. 25 over 5 becomes x minus 5, but the second one doesn't reduce, so this is still going to be plus 33 over 5. Now this is where we have the bottoms up piece, so anything left in the denominator comes up to be the partner coefficient of your variable term. So this is going to be x minus 5 times 5x plus 33. And there we have our factors. Okay. So once we have our factors, we can go in and we can finish solving your problem. So the problem wants to know the dimensions of the rectangle. So we have to remember that these factors are still set equal to 0, which means we have to solve each. So we're going to solve x minus 5 equals 0 and 5x plus 33 equals 0. So again, we're going to have that x equals 5, and we're going to have that x equals negative 33 divided by 5. Since we're dealing with units of measure, the negative goes away and leaves only behind my term. Now when we were doing this, notice my initial variable was the w. So what we found here is we actually found our width. So our width we have found to be 5. So here my width has found to be 5 inches, which means my length is going to be 2 times 5 plus 2. So 2 times 5 is 10, plus 2 is 12 inches. So there you have it. You have 3 fairly extensive different geometry problems, each problem looking at solving through the use of quadratics and using factoring as your method. So if you have any questions, please let me know. Otherwise, I hope you enjoyed this version of looking at geometry in terms of algebraic problems. Remember to keep smiling, have tons of fun with your math, be very creative with your approach, and I'll see you next time.